Hey guys, it's Simon and welcome back to another part of the LibGDX Kotlin RPG tutorial series. And as mentioned in the last part, in this part we are going to cover the user interface with Scene2D, which a couple of you requested in the comments area of the original last part of this tutorial series. But as mentioned, whenever you have something that you are interested in, just let me know, then I can create another part for that and make a video out of it to show it to you. And what we are going to develop is I opened here the original project from the GitHub repository, and now in this part we are going to develop a user interface which will look something like that. So at the bottom we have our player where we can, when he takes damage, his life bar will get adjusted according to how much life he has left. I also introduced already a mana bar. We actually don't have spells and cannot cast anything, so that is actually a useless bar for now, but maybe if you want to improve on that, you can introduce spells and everything, and that would be already available. So we will develop that. Then when we pick something up from our loot, there will be now a pop-up showing up, which is simply this table here, which gets faded in, lasts then for 4 seconds, and then it fades out. So this is what is going to happen then when we interact with a chest. And the final thing, which is a little bit clunky maybe, but also not sure if that is the best way how to do it. But when you damage an entity, or when an enemy, or when an enemy actually is going to attack our player, then there will be a pop-up at the top which is showing the current entity which is going to attack you. Also, that entity has then the information of the life and the mana that it still has left. And after 5 seconds, if nothing is going to happen there, then also this pop-up here is going to disappear. And when it appears, you see there's a small little blink animation. So for example, if a slime is attacking us, it will fade in like that. And then when we damage it, of course, then the life bar of that entity also gets updated accordingly. The mana bar, as mentioned, is not doing anything for us. But this is the user interface that we are going to develop. So there on the GitHub project, I created a little bit of a test screen, and I also created a test folder for that, which was a little bit easier for me to develop the user interface. And also just that you see it in the final game, let's also start that up from the GitHub repository. So there you see now, so at the bottom we have this player with all his values. Now the slime was attacking us, so he was fading in at the top. And when we, for example, damage it, then you see the life bar gets adjusted. Also when he damages us, our life bar gets adjusted. And one final thing, let me go up to the chest here. So when we interact with that, then there will be this pop-up that we found something, and that one then goes away. So this is the user interface that we are going to develop in that part. So if you're interested into that, then stay tuned. Okay, so let me switch to our project now again. And yeah, so when it comes to user interfaces in LibGDX, there is, from what I know, only one base solution for all the user interfaces, which is Scene2D, which comes with LibGDX. And luckily for us, we already used it a little bit because, for example, for the rendering of our entities, we used an image actor, if I remember correctly. We already know what the stage is with the act and draw stuff. We already rendered some text, so the damage text, which was, I think, a label, if I remember correctly. So all of that was already Scene2D. And I think I explained a couple of these concepts already in the previous parts. So the good part is you are already familiar with that. Now we are, of course, making a little bit more of a static, real user interface in that part. I did already make a tutorial about how to make a menu and so on in one of my last tutorial series. I will add the link in the video description below if you want to see, for example, how to make a progress bar while your assets are loading, how to make a button, or when you touch or click on the screen, how to react on that. So that one was covered in one of the previous videos. So here we are really making this dynamic user interface that I was just showing before with the life bar and so on, and the pop-up, which I think is interesting and does not overlap with what I already did in some previous videos. And some people mentioned that they would be interested to use or see VisUI, which is also a user interface library for LibGDX. And I never used that, and I looked into it, and from my understanding, it's actually the same, or not the same, but it simply also uses Scene2D in the background. And the difference is that that one comes, from what I understood, with a default skin, so that for all the different widgets that you have, you already have a graphic available. We come to that in this part in a moment to explain it a little bit in more detail. And I think it has some additional custom widgets, so with additional support. I don't know, like for example, for a button, when you hover over it with the mouse, that there could be some specific style with that. Same for the label and so on. So they simply have some additional widgets with additional graphic support, from what I understood. And in my opinion, this is not needed for what we are going to do. So that's why we don't use VisUI here. We simply use the Scene2D core stuff. But I guess, or I pretty much sure that when you understand those concepts and know how to use it, then you also understand VisUI and could use their widgets then as well. But as mentioned, we don't need that for the user interface that we are going to develop, so that's why we skip VisUI and we are only to use Scene2D, the core stuff. Okay, so to start with that, I would say to make it easy for us and to don't interact with our main game for the time being, that we simply create a new screen for now, just to create the user interface part. And also to mention it here, I'm definitely not a user interface expert, and I always struggle with it to achieve the way or the look that I wanted to achieve with something, and it's not easy for me. So definitely if someone has some ideas or some hints how to improve on certain things, then please let me know. I'm just showing you the way I'm doing that. I think the solution that I'm going to show you is quite a good one. I've thought about it and developed it the last 2 or 3 days, and I like it the way I did it, but again, not sure if that is the perfect way or the ideal way how to do it. It's just one way how you could do it. And usually what I do, I create a separate screen like this test user interface screen that you saw before, where I can quickly play around just with the user interface part. So I just want to see my widgets and everything. I want to be able to quickly reload everything. So for example, when I move something a little bit, some pixels to the right or left, or give it some padding or spacing in between or whatever, or try out the animations with the fade in, fade out stuff, I want to be able to quickly get feedback. So when I adjust something in the code, I want to immediately test it without always closing and rerunning the application or getting distracted with my normal game logic, like the player dying in the background and things like that. So that's why I usually develop that separately. And that is also what we are going to do here. So let's create here simply a new screen. Let's call that also the, I don't know, just UiScreen for now. And that will be our normal, I think we use the KTX screen, right? Yeah, we extend from KTX screen, so we did not have a special screen here. And of course, in our main game, just for now, we can still add the game screen, of course. We can also add here the UI screen. And the only difference is now that our set screen is not the game screen anymore. For now, we want to go to the user interface screen to try it out. So now we are independent and can develop our user interface. And what do we need? So we actually want to develop a user interface for our user interface stage here. So just to take that over, to have the same settings that we then have in our game, we bring here over our stage. And as you already know from the previous parts, so in our render method, we simply need to call the stage act and the stage draw function. And also the resize stuff and so on. So this is everything that you already know. So I will skip that. Okay, so this should be the boilerplate implementation for our user interface test screen stuff. So we have the stage as mentioned. When the window gets resized, we resize the viewport. When we show our screen there, we're going to add something in addition. Then we first of all clear the stage, so we remove all the actors which were added to it, and then we add them new. Because in our render method, where we call the act and draw function, we want to simply reload our user interface. This is as mentioned, when I change something in the user interface, maybe the way I add an additional widget to the user interface or anything like that, then I simply want to reload my codes. I show that to you in this part, of course, as well. And then with pressing R, it rebuilds my user interface so that I can get a very fast feedback with developing the user interface. So this is how I do it. And of course, when we dispose the screen, we will also dispose that specific stage. So that would be it. And now we are going to start with the view. So just as a reminder from what we've seen before, let me quickly open up a screenshot. So let's start with that widget here at the bottom. So this player widget with a live bar, mana bar. And we want to adjust then here the bars that they go from right to left or left to right when we take damage or when we get healed, for example. So let's start with that one in our view. I think that's a good starting point. So there are normally different ways how you can develop a user interface which needs to interact with your game itself. Just to mention 2 of them, there would be a model view controller. I think it's a pattern actually, where the model would be, for example, everything that we have developed so far. So our entities with the components and so on, that would be the model. Then the view would be the user interface. So for example, this live bar, mana bar, the little widget and frame for our player, that would be the view. And the controller would be something in between. So between the model and the view, there would be the controller. And the controller, for example, reacts to when a player gets damage, then the controller will update the view with the information that it has, and also backwards when the user interface would change something, for example, I don't know, a button click, or the user enters a text in a text area to give the player a name or something like that, then the controller would write that back to the model. So this is this model view controller pattern, which I used sometimes in the past. But what I prefer nowadays more is the model view model approach that we are going to implement in this part, which is very similar, but it's, in my opinion, it has some benefits when it comes to testing and also the way it is developed. I like it more. So MVVM, you still have the model. So again, our entities and the components. Then you have a view model, which is like an abstraction, I would say, of your model, which contains all the logic that you need for a specific view area. So in our case, we have we will have this game view model, which has the information of the player life, the enemy life, when we open the chest, what kind of text is showing up. So all the logic that is necessary for that specific part will be part of this view model. And then there is the view, which is the same as in the model view controller pattern, which is just the user interface. The important part is the view actually gets access to the view model. And then I think from what I read in the normal model view model approach, the view can then bind certain properties of the view model to its widgets, to this user interface stuff. So for example, we could bind to the live property of the player and bind it to our live bar, and whenever the player live changes, so this property changes, then the bar gets automatically adjusted. This is normally supported by some of these libraries or frameworks out there. Unfortunately for us, Scene2D, from what I know, does not have that, so we will implement our own data binding mechanism, let's say here. It's a very simple one, but I think, at least from my personally feeling, what I developed there in the last couple of days, I like the approach for a simple interface that I developed there. It was easy to set up the test screen, so that was one of the benefits with that approach. And yeah, in general, I just liked the separation of the different code pieces that I had, and the binding or the interaction between our view model and the view was then very convenient. You will see that then in this part. Okay, and as mentioned, let's start with our view. So first of all, we are going to create a new package for our user interface, and there, for example, a sub package for our view, and there we can create a new class which we call, for example, the game view, which will be the view for our game that we have. And since we are using Scene2D, we are going to use a specific widget for our game view, which is a so-called table, which I think we did not use that, and the table always or can require a skin. I will explain that in a moment. So the skin, I mentioned it briefly in one of the videos, I think. It simply contains the information of the different styles that the widgets have. So maybe you remember it in our live system, we created a label style which contained the information, what kind of font will be used, what kind of color does the text have. And I mentioned it, I think back then, that there are different styles. So there's then also a button style, a text area style, a scalar style, whatever. So whatever widget you can imagine in a user interface, there's normally a style for that available, and a convenient way to not create all these styles manually here and access them then in a special way. So a convenient way for that is the so-called skin, which is simply a container for all the different styles that you want to use in the user interface. Plus you can register additional resources to it, which are maybe not style related. Maybe, for example, you just want to have a font in your skin available, or different fonts, one for a title, one for a normal text area, things like that. So all of that is part of a skin, and you might have thought of it already. A skin can then be simply disposed when you no longer need it, and then it takes care of disposing all the resources. So for example, the different textures which need to be loaded for a button background, a table background, the different fonts which are registered, all of that will be then disposed with the skin. So the skin is this bundle of the different styles that we are going to need. And unfortunately, there is no default style built in. I'll show you that in a moment. So our view for now, let's just add a label to it, and there we will see that this is not working. So there will something crash because of a missing style. And there I will show you then how we can create a style for that and how to create the skin. So this is everything that we need for our view. Then, because we are using libKTX, we actually have some nice DSL available to set up our user interface. And when you want to have that your custom widget. So in this case, for example, our GameView, when you also want to use that in the Scene2dDsl, then they suggest in the documentation that we also implement here, because we have a table. We also should implement then this K table from KTX, which gives us then some extension functions in the DSL when we come to that later on. I did not explain yet what is a table. So a table, you can imagine it a little bit, maybe you are familiar with web development. So a table is like a white board, let's say, and there you can add different widgets to it, and a widget is then always contained in a cell, and the table then simply consists of multiple cells, and you can then arrange and style the cells the way you need it. So maybe I don't have a simple drawing program. I think, yeah, I have Paint, because Windows always has Paint, which is great. So a table can be, for example, like that would be our table, and then you can imagine we will have, for example, a label that would be added, for example, here, which contains some text, and the label is then inside of a cell of that table, and that cell, so for example, I cannot make errors, so that would be our cell here, and inside the cell there would be the label with some text, and this cell you can then say, for example, inside the table, should it be at the top of the table, at the bottom, left, right, should it fill up and expand all the available space that it has available, or should it be as small as possible, and things like that. So the table is like a dynamic container to easily create your different, or arrange your different widgets that you want to add to the stage in a convenient way. So we see that in a moment, but this is the idea behind that. So you don't add a label and position it manually on your screen. We use the table, where we simply add the widgets to our table, and then the table in the background contains all the logic that it needs to correctly lay out the different widgets that we add to it, or actors as it's called in Scene2D. So this is the purpose of a table, that everything is calculated dynamically for us with the layout, that we don't need to do that for ourselves. Okay, and our game view, there we have an init functionality, and there we are going to add now, let's say, simple, just a label that we see that. So first of all, a table has an important functionality which is called setFillParent, which means if it should fill out the entire space that is available from the parent. So our parent will be our stage, so the user interface stage, and we simply want to fill the entire screen or the entire viewport of our stage. We want to use all the space which is available, so that's why we set this setFillParent to true. If it would be false, then the size of the table is, I think, the smallest possible size to draw all the actors that were added to the table, so that is available. But we don't want that. We want to fill out the entire space, so we set this setFillParent to true. And we are also going to add now a label to it, and there we have the KTX extensions. So there we can add a label, and for example, a test text, whatever. You see already to the label, first of all, we need to provide a text. So what should the label show? Then a style, which is coming from the skin, and that you don't need to specify a specific name for the style all the time. There is like a so-called default style in Scene2D. I think it's a simple string representation of default. I think that is the string for that, but that is provided per default, so we don't need to provide that. If our skin has a default label style available, then it will simply use that. And with the skin, there's also a nice functionality with LibKTX, because you can imagine it's a little bit annoying to pass the skin to all your different widgets that you have available. So that's why libKTX provides there a global variable, this Scene2D skin default skin, which is also the default value for any skin argument of the Scene2dDsl in libKTX. And then normally for every DSL, so at the end, you can then configure your specific widget. In this case, it would be a label. And there you have always access to two things. So first of all, the label itself with this argument, and you also have available to the cell with by default with the it stuff of Kotlin, but you can also override that, so you can name that cell or label cell or whatever, and then you can adjust the cell a little bit, which we do then with some of our widgets in the near future. But for now, let's just add this label for now, and that's it. Okay, so in our user interface screen, let's go back to that one. we want to add our game view now to the stage. So there's also an extension function available in LibKTX, which is called actors. And within that actors block, you can now specify the different widgets that you want to add. And there we want to add, for example, our game view, where we pass in the skin, and there let's just take the Scene2D skin, the default skin for now. So actors, what is that? This is simply convenience function. I think we did that already in some other parts. So there's the stage add actor function, and then you would add the game view, for example, to it with the skin. And instead of writing all the time stage add actor for all the different widgets that you want to add to it, there is this actors function available in libktx, which simply then does whatever actor you add within that block. That one will get automatically added to the stage with that call in the background. So it's a little bit nicer to read, in my opinion, when you set up your stage. Okay, and to quickly also show you the default skin. So per default, if the default skin is not defined, it will throw an exception that you did not set up a skin yet. Otherwise, it will simply return that skin. So for now, also just to, maybe I show it to you. When we start now our game, we should get an error that the default skin is not available. Yeah, default Scene2D skin was accessed before initiation. So just for now, I explained the details and the setup in a moment. For now, let's just initialize it with an empty skin to get rid of that error. And now let's start up our game once more, and we should receive another error, hopefully. Yeah, exactly. So here you see that now. So coming back to our game view, we want to add a label to our table. But as mentioned here, so there is no label style registered with the name default. So we are actually missing this style information, how this label should look like. So what kind of font should it use? What kind of color should the text have, and things like that. And as mentioned, there comes the skin into play. So we're going to set up now our skin. So what I usually do there is that I just create a new file. Let's call that skin. And I want to have that actually in the user interface package and not in the view package. Let me also quickly change that. Okay, and there we want to have, for example, two functions. One would be the load skin, which you just need to call once. So this is the initial setup of our skin. And when we are done, so when we are closing our application, for example, then we call the dispose skin function, which is simply from the default skin that we are going to set in the load skin function, and there we call the dispose safely. So that would be it. So those are the two functions. And up in here, we set now the default skin, as mentioned before. And there is also a libktx function available, which is the skin function. And there you can provide certain information of the different styles that we are going to use or register for our skin. And I just see we did not add this extension actually. So let's add that. So in our build Gradle file where we have the KTX Scene2D extension, there we also need the style extension. Then let's quickly refresh our project. And now we should have the skin extension available. Yeah, perfect. So this will then set up our default skin. And here, as you can already imagine, a skin might need access to different graphics. So as mentioned, like a background for a button, for a label, for a table, different images, for example, our frame, our life bar, our mana bar, and all of that. And this is again normally bundled together in a texture atlas. And I already prepared that. So there I would suggest simply use the one from the GitHub project. So in the assets folder, there is a user interface folder. And in that folder, you can download the atlas and the PNG file. We already created, for example, an entity atlas and a map atlas from what I remember in the tutorial series. So I'm not going to cover that again. It's simply the same. The graphics that I used are also mentioned in the GitHub repository. Let me quickly show you that. So there's the credits area, and for example, the user interface assets. Those are the ones that I used, and there I simply adjusted it a little bit. So for example, I removed the gold area here of this pop-up frame and some other minor adjustments. But in the end, it's that graphic or that asset package that I used for the interface. And I should suggest simply download it and use it so that we have it available. And this is the first argument actually of our skin. So there we need to provide the atlas information so that we have access to the different graphics. And there we simply create a new texture atlas and load the one from our user interface folder. And this atlas, so when the skin gets then disposed, the atlas of course also gets disposed. So the skin is taking care of that. And then we have a configuration block where we can now define the different styles that we want to have in our skin. And for example, for now, we want to have a label style. If we don't provide any name, then it will be this so-called default style that the Scene2D library is trying to load. And there we are going now to define, for example, the font that we want to use for this label. And yeah, that's it. So font, we also did that already in a part before. There we created this damage font. And here also I just download now the one from the GitHub project. I used a different font for the user interface, and I will just copy now the font file into this user interface folder so that we have that available. Okay, so I called that font white, and just that you see it. So in the atlas itself, there is a small area, that one here, which is the bitmap graphic, so the font graphic that we are going to use. So this font white, there is this region in the atlas for the font white graphic that we can then use the text in that. So it's part of the atlas actually. Okay, and just quick and dirt for now, we are going to load a bitmap font. The file that we are going to use is from our user interface folder, the font white font file. The region, so where can it find the texture for the bitmap font? This is coming from our skin itself. So there's also a get region function, and this is just the font white region. Oh, we also need to close that here. And I think that would be it. Yeah, so we have now a font. We are going to improve that very soon, but now we have a default label style. The font, I think, is the mandatory information for that. And now we should already see some text. Okay, so we can remove the call in our user interface screen because there we don't need that anymore. And let's, for example, here, when the screen gets created, we also load our skin. And in the dispose function, we dispose our skin so that we make a call to load, also to dispose. And that should be it. So hopefully we see now already some text when we start our game. Okay, we don't see a text yet because I forgot something actually, which is mentioned in the LibKTX documentation. So I will also add this description in a link below. And when you create a custom widget, so like for example here, he also creates a custom widget in the documentation with a table and KTable like we did it. But what we did not do yet, we need to create an extension function to this internal LibKTX widget to correctly add our widget to the actors of the stage here. So that call here creates an instance of the game view, but it does not automatically add it yet to the stage, of course, because how should it do that? So for now, just that you see it, let's add here a stage add actor for just that we see that it's working with the label now. So now the stage has then a single actor, and now we should see some text. Yeah, perfect. So now we have this test text here available, and we are going to fix that we can use it in a nice DSL way with the LibKTX extensions as well. So this is a small thing that we need to do, but to quickly recap a little bit, because I think that was already a lot for now. So we have a stage in Scene2D, and to the stage we add our actors, so the different view or user interface elements that we want to have. For now, we create this game view, which for now is just a table with a label, but very soon it will be the player frame with the live bar, the pop-up for the chest and so on, the enemy, pop-up and things like that. So all of that will come to our game view actor here, where we use already the LibKTX extensions. And there we want to use the DSL as well with the actors to nicely write down our view and to see it how it's combined or arranged. And in order for Scene2D to work, we need a so-called skin, which we created now with the skin extension from LibKTX, which gets access to the different user interface graphics, which are normally bundled in a texture atlas. And there we define now those different styles for the different widgets that we want to use. So for example, for a label, for a text, for whatever. So there you have or need to define those different styles, because otherwise, when you create a widget which does not have a style, then it simply will not work and will crash. And of course, at the end of our game, we will dispose our skin, so to also release all the resources which are related to our skin. Okay, and to fix that one here, we want to have to support also the libKTX extension. So we want to write something simple like that. So we just want to add the game view, and maybe after that some special block to adjust the game view a little bit. And how does that work? So there we need to write an extension function down there, which first of all we add this Scene2dDsl annotation. From what I know, this helps the Kotlin compiler to know what kind of functions are available in a specific code block, and with that annotation it suggests then our new function that we are going to create in the Scene2dDsl of libKTX. And how does that look like? So we have a function of a specific type S and an extension for the libKTX widget of type S as well. And there we have our game view. And the game view for now, it takes a skin, which we can default to the Scene2D default skin. And it has an initialization block, which is also from our game view. Takes in that specific widget type and returns something, and by default it can be an empty initialization block. And what that does, it returns a game view widget, and it also needs to add that to the K widget. So in our case, the K widget will be the stage, because we are inside that stage actors block, and from that stage to the stage we want to add our game view. And there is another function in libKTX which is called this actor. The actor is actually now our game view, where we pass our skin and also the init block to this actor function, and that should be it. So now when we are here, we can add now this game view functions. So again, we are in that block inside of this, they call it here a stage widget, which is simply a wrapper around the stage. And from this stage widget, that will be our K widget here. That one calls the game view function and will add this actor directly. So this actor function in here, there you can see that it calls this init function that we pass in here, which is optional, and also calls then this store actor, which is nothing else than, I think with the stage widget, it's simply calling this add actor functionality in the background. So now let's come back to our game view. To our UI screen. There now we should still see the text and everything should work. Okay, perfect. So this was this small extension function that we needed to write to support the Scene2dDsl part. One important thing here, just that you also heard of that, because I was confused of that a few days ago when I used it. With libKTX, there are two types of functions available when it comes to Scene2D. So there's, and in my opinion, it's a little bit confusing, but I also don't have a better idea. So there's, for example, a table function. And there are two types of table functions. So there's one table function which creates a table widget, and that's it. And then you just store it in a variable. So for example, you want to create a table here. Then you use the Scene2D table function, and that one creates now this table in there. And later on, you can, for example, add this table to your stage with, for example, add actor, and just use that later on. But there's also the same function, so this table function here, and that one is actually this special extension function that we wrote now here, which creates a table but also adds it automatically to the parent. So the parent would be the widget from the current scope, so in that case the stage. But could be, of course, you can nest that. So for example, here there's also a label function. So now the parent widget of this label would be that table. And it's a little bit confusing in my opinion, because table and table has the same name, so it looks the same, but it's something completely different. And to distinguish that and to not get into troubles with the DSL itself, at some point in libKTX, he added this Scene2D prefix here to make it clear what you are really using. And as a rule of thumb, when you use the prefix, so the Scene2D, then you are creating the widget and you are not adding it automatically to an actor. You need to do that manually yourself. So this is when you use the prefix to just create the widget, but don't do anything special with it. And when you don't use the prefix, like here, then you create the widget, but in addition, you add it automatically to the parent that you are currently in there. And this could be confusing. So for example, when you write something like that, then you simply never see the table. It looks like you want to add it here to the stage, the way it's written, but it won't work because we are using here the prefix. So the important part is, Without prefix, you add the widget automatically to the parent, and with prefix, you just create the widget, but you don't do anything with it. So this is important to understand and to keep that in mind. So I had a problem a couple of days ago, raised the issue on the LibKTX GitHub repository. The guy has always responded very quickly and helped me a lot, and he added now some explanation to the documentation. And yeah, now at least for me it makes sense, but be aware of that, of this difference between the Scene2D prefix and without the prefix, so that there are always two functions with the same name, but they do something completely different. So keep that in mind. For us now, let's remove all of that because we just want to have our game view for now. Okay, so let's create our character information widget. So that would be what we saw before. So the player with the life bar and the mana bar. And just that you see that as well. So graphics wise, there is first of all a life bar in our atlas, that is the red stuff. Then there should also be somewhere, okay, up here, there's also a mana bar, which is the blue bar. Down there. Then there are different icons in our frame. So for example, if we want to have the player life bar, then this player will be part of the frame. And if we want to have, for example, the slime in our frame, then we will use the slime graphic up there. Then we have the frame itself. In here we place the life bar, the mana bar, and this icon. And I think that's it. Yeah, so there we will create now a widget that contains this frame, the life bar, the mana bar, and this information of the icon here, what kind of character it is showing. For that, what I normally do when I create a custom widget, I create a new package, which I call widget. And there, let's create now a character information widget. So what is this character information? It's simply a bundle of images, let's say. And there's, yeah, I would call it stacked on top of each other. And there is one widget already available in Scene2D, which is called stack. And you might think, hey, that's the perfect match, but no, the stack is not what we want. Don't ask me why. It's simply, when I tried it out, it rendered it completely strange and not the way I would expect it to render. So what we actually need is a widget group, which is very similar to a stack, but the way it is laid out, it's just working differently. So what I wanted to achieve is that I just want to stack images on top of each other and then just with a specific offset position them correctly, so that when we go back to the graphics, so that, for example, the life bar is correctly positioned within that area here of the frame, and the icon here is correctly positioned in here. And I could not achieve that with the stack so easily because it does something. Don't ask me what exactly. What I just found out, the widget group is one level before the stack, and that is what was working for me perfectly. So there we use a widget group, and again, to be consistent and correctly working with the LibKTX extension, we will use the K group, which is similar to the K table, but we don't use a table here, we use just a group. Okay, and what we have here is we have 4 elements for our character information. We have the background, which is simply an image. We already know that from our other things of our entities. For example, we use an image, so there we create a new image, and the graphic that we are going to use, so this drawable that we are going to use. Not sure if I explained drawable, I will do that in a moment. We will set that then according to our skin. And we don't only have a background, we also have the, let's call it the character background, that will be this icon. Then we have the life bar, and we also have the mana bar. So those are the 4 elements which we need in our widget. And then, since we have a group, we now want to add those different elements to our group. So to our widget group, we add the background. There's also a LibKTX extension for this plus equal, and the same. So first we add the background, then we add the character background on top of that, then we add the life bar, then we add the mana bar, and that's it. So very quickly for now. So those 4 images will be part of our character info widget. So when it comes to a widget group, and also to the layout in the table with Scene2D, so in order for the table to correctly lay out our widgets, it needs to know, of course, what is the width and the height of the widget that it can place it correctly, for example, for centering and other things like that. And there are 3 different information in Scene2D with every widget. It's the minimum width and height, it's the maximum width and height, and actually 4. It's the preferred width and height and the actual width and height, which is then really used when something is laid out. Minimum and maximum, I think, makes sense. So it's simply the minimum space that your widget requires and the maximum space that it should require, and everything in between is then allowed. And the preferred width and height, don't ask me. I personally find Scene2D very confusing. The preferred width and height is then most likely the suggestion. So please use that width, and that somehow overrules minimum and maximum width or whatever. And yeah, for whatever reason, just define here in our widget group, which has by default, I think, a width of 0 and a height of 0. So it would not know how to correctly lay them out in a table. So that's why we need to overrule here the preferred width and height. And there we simply take from our background graphic, because that is the biggest part of our widget, and there from the drawable, so from the texture that is then really used. And there we use the width. And the same for the height. So there also from our background graphic, from the drawable, we use the height. So this is what we need as an information, so that when we add this widget to a table, that it correctly lays it out. Okay, so drawable, I think I did not mention that yet, so let me do that. It's simply a wrapper in Scene2D. So I think until now, I assume that we always used a texture region for our image, but in Scene2D, they work with drawables normally and not with the texture or texture region information. And yeah, a drawable is simply a wrapper around the texture region, but it has some additional information. So you could, I think, use or add a drawable to a stage. It's already an actor, I think, and has information like position, rotation. I don't know. We can quickly check that out when we use it. But yeah, just for your information, it's simply a wrapper around the texture. And we want to get that from our skin. And there is, we of course need to pass in the skin here as well, as with all other widgets as well, so that we have access to that. And from our skin, we get the a drawable with a specific name. So for example, the CharacterInfo background or whatever I called it. I personally don't like using hard-coded strings throughout my code base, because I always forget how I called things and what I need to do. So we are going to create an enumeration here in a moment to avoid that problem, but just that you see how the normal call would look like. So from the skin, we can get the drawable with the key of our atlas. So in our atlas, that specific region here has a specific key, and with skin get region, we simply get that texture region and already wrapped inside a Scene2D drawable. And out of curiosity, let's quickly check what is a drawable. So it's just an interface. Aha, okay, so it has some, yeah, but it has this information, so it would know how to draw itself. So this is what I mentioned, the texture, a texture region does not know how to draw itself. It's just information about the texture or the region of the texture, and a drawable could be used to already render itself. So for example, we could make a call to the draw function of a drawable, provide the sprite patch and the position and the width and height, and then it will render the texture or texture region in the background within those boundaries. So this is the drawable in Scene2D. Okay, so as mentioned, hard-coded strings, not a big fan, so we will fix that. And I normally do that here in the skin. So what I normally do there, I create an enumeration. Let's call it, for example, the drawables that we are going to use. And there we have like a CharacterInfo background. If I could type, then we have a life bar, we have a mana bar, and just for now to start with something, we have our player icon. Again, if we would use the proper naming conventions, we could use those names already to look up the regions in our atlas, but sometimes I name my images differently when working with user interfaces, and I don't want to change the file name or something like that. So that's why I provide here the key of the atlas that we are then going to use. So that would be, for example, the character info, that would be player, here it would be life bar, and here it would be mana bar, and then of course every drawable has an atlas key, which is a string. Okay, and then what I also like, so I don't want to write everywhere skin get drawable and then drawables drawables blah 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 dot atlas key. I don't want to write that. I want to write something like that. So I just want to have skin, and then, for example, drawables dot player, something like that. And to support that, because we are using Kotlin, we can of course write an extension function for our skin, an operator function of the get operator, and there we pass in a drawable enumeration, and we return a drawable from Scene2D, and this is simply a call to, let's implement the skin, to the get drawable function of the skin, and from our drawable that gets passed in, it is the atlas key that we need. Let's remove here the S, I don't like it. So it would be something like that. And with that little extension now, we can go back to our character information. And here we can now write something like skin drawables character info background. And yeah, import the get function here. For whatever reason, I could not do that automatically. But I know that problem, so I just manually import now this get function from the skin. And now we can write something like that, which is great. And for the remaining images, so here we want to have the life bar, here we want to have the mana bar, and here this should be a little bit dynamic. So we don't want to have the same character icon for our character info all the time. So ideally, you can pass that to the widget, what kind of drawable you want to show there. And initially, for example, for the enemy, it could be even null. So if we don't want to show any specific image for this character information, then it could be null. So we pass it in from the outside, and then in here we simply check when we create the widget. If the char drawable is null, then we use null as a drawable, then it's just an empty image. And if it's not null, then from our skin we get this drawable that gets passed in. Okay. And the thing that we are now missing is this extension function again. So let's write it down one more time as an exercise. So Scene2dDsl, we have a LibKTX widget. This will be our character info. What you can pass in here is the character drawable, which can be null. Again, the skin, which defaults to the default skin of LibKTX Scene2D, and an initialization block for our character info, which takes in the specific widget. And by default is empty, so you don't need to specify anything special. And it returns a character information widget and adds it to the parent. And there we create it now. So we pass in the character drawable and the skin and the initialization block. And that's it for now. So let's try that out. So when we go back now to our game view, to our table, there, let's remove the label now. We don't want that. Now we want to have character information. And for example, we want the player drawable. Okay, so let's see how that looks like. So we see already something, which is great. So we have our table, which it might be a little bit weird why it's showing it up there. Let's turn on the debug mode for the stage as well, that we can better understand that. But we see already our frame here for our character information. We have the player icon, we have the life bar, and we have the mana bar. They are not positioned yet correctly, so everything is located at the bottom left of that widget, but it's already a good starting point for that. So coming back to our character information. So currently we simply add all those graphics there, but we need a specific offset now for the different things to position them correctly. So for the life bar, for example, there I tried it out. So the position that we want to have, it's 26 pixels to the right and 19 pixels to the top. For the mana bar, we also want to adjust the position in our widget group, which is again 26 pixels to the right and only 30 pixels up. And for the character information, there we also want to adjust something. So there the position would be only 2 pixels to the right and 2 pixels to the top. So now those graphics are already adjusted a little bit, but we want to turn the debug mode on as well, so that we better understand what is really drawn. So here in our user interface screen, let's turn on is debug all. So then we see some debug lines and better understand how things are drawn. So here you see at the moment, I think that would be our table. Not sure why there's a gap between the top. I need to check that. And in the center of our table currently, there would be our character info widget. And there you see now, so already the positioning is now better. So the live bar is correctly positioned, the mana bar is correctly positioned, and the character info is also here at the bottom left of that corner. But it does not fill up yet the entire space here. So let's also fix that here as well, so that it's really filling out the entire space of the character information. And with the image, we can simply say it should scale the drawable inside to still fit inside that area without disturbing the aspect ratio. Okay, so a small fix to our character info here. So we don't only set the position, we also set the size of that element here, which is 22 pixels by 20 pixels. And we set the scaling mode that it should contain this graphic. So now that should even look better. Okay, yeah, so now we see that the character information image is filling out the entire space and simply gets scaled up here to contain or to be part of that area here. So looks good. So the character info widget is almost done. So graphically it's fine. Now we just need some logic here that the live bar and the mana bar can move to the left and to the right, because currently it's just a static image, but of course we want to add there some logic to it. I just found the problem, sorry, in the resize function, I forgot to pass in here the information that the camera should be centered. That was the reason why the table was rendered a little bit offset. Now you can see, so now the blue borders are correctly around the entire screen. That was the problem why there was this gap at the top. So now we correctly have that in the center, which is great. Okay, so coming back to our character info widget, we need two functions for now. I will ignore the mana part for now, because I think it's the same as with the live bar. You can check that up in the GitHub repository. Also for our game, it's not necessary because we don't use it. So what we want to have for now is our character drawable. We want to be able to change that. So there you pass in a new drawable, and then we have two things. So if this passed in drawable is null, then from our character background, the drawable is null, and otherwise the drawable will be updated. Oops, from the background, the drawable will be updated to our skin and the drawable that we pass in here. So the skin, we don't remember it yet, so let's remember it there, that we can reuse it here. So with that, we can now adjust the icon of our character information. And the next thing is from our live bar, we want to be able to adjust that. And there, let's say we pass in a percentage, which is a value between 0 and 1. And you can also pass in a duration. So how long should it take to scale or to move to that specific value? By default, let's say it's 0.75 seconds. And then we do the following. So from our live bar image, we clear all the actions, and then we add a new action, which is the scale to action. Okay, and that one takes in a value. So we want to scale it on the x-axis and also on the y-axis, and to which value. So on the x-axis there, we want to scale it to a value between 0 and 1. So we are, whatever value we get in here, we clamp it. So the value is the percentage value. Minimum is 0, maximum is 1. For the y-axis, we always want to have it at 1. So there we never scale it. And how long should it take? There we pass in the duration. And that one should be able to import it like that. So then it's a little bit easier to read. And yeah, so that should be it. So let's quickly go back to our game view and let's remember that. So there we have, let's call it the player information, which is a character info. And that is simply the widget that gets in here. And then the view need to be able to adjust it. So let's say here we want to, let's actually add two, because we also want to test the character icon change. So we also will have an anime information, which is from a table point of view above the player. So here we have an anime info, something like that. And now we are going to implement two functions. So first of all, the function, the player live, for example, which takes the percentage of the live, which is a float, and does something. And we also have, for example, the show anime information, which takes in drawable, so what should be shown there, and also the live percentage of that anime. So player life is fairly simple. So from our player info widget, we call now this newly created life function and pass in the percentage here. So that one we can actually convert to an expression body, then it's a little bit smaller. Show enemy information is a little bit different. So there from our enemy info widget, we want to set this character information, which is the drawable. Again, let's call that character drawable. And also we call the not the label method, we call the live method and pass in the live percentage. And maybe initially, let's do that now with a duration of 0 so that it immediately jumps to that specific value, which is already quite good. And now let's test it. So let's go back to our user interface screen. And now we add here some additional test stuff. So for example, when we press number 1, then we want to do something. When we press number 2, we want to do something. So let me add here a couple of test functions. So in order to test that, we need to remember our GameView, which gets initialized in the show method. So it needs to be laid in it. So let's store that in here. And now, for example, when we press 1, we can set the player life to 0. When we press 2, we set it to 50%. And when we press 3, we set it to 100%. And when we press 4, then, for example, for our enemy, we want to also show the slime icon. So maybe let's add that here as well. It's another drawable of our atlas, the slime. So let's change here to slime. And a life of 50%, for example. Okay, so let's test all of that new stuff now. Okay, so first of all, I forgot to make a new row for the enemy and player widget, but now let's try. So we press 1, that adjusts the player life bar to 0. We press 2, it goes to 50%. We press 3, it goes back to 100%. And we can quickly press around the number buttons and we see that this life bar is already moving correctly. So this is one part of our user interface, which is great. When we press 4, we change now from the player to the slime, which is also working, and we change the life bar immediately to 50%. So this is also working. So I would say our character information widget is working quite well. What we are missing currently is that those two widgets should not be in one row. And how can we fix that? So when we go to our game view, with our enemy information, here we need to make a call to the cell. So the cell is here it, and there we make a call to row. Row means that the current row of the table that we are filling with different widgets is simply making a line break. So with that simple call now, those two widgets should be below each other. So now we have here, what was it for? So this is the enemy information or character information, and below we have the player information. Currently they are in the center, but we are going to add another widget in the center of those two. So in the middle of those two, then the enemy would be at the top and the player at the bottom. And that is the user interface that we are trying to achieve. Okay, so the last thing that we need in our view is now just a pop-up when we would interact with a chest, so that we have a pop-up for the text and everything. And there is one thing that I want to show you. So when we go to the graphics from our texture atlas for the user interface, so the original graphic, for example, for the background frame and the foreground frame look like this. So let me quickly open it up. So for example, the background looks like this. And now you can imagine, so this has a, I don't know what size, so about 50 by something, 47 by something size, which might not be sufficient. So we need it maybe in different sizes, because the text could be very long, could be short, and maybe according to the size of the text, we want to adjust the background. And by default, of course, the graphic would simply be scaled, which would also mean that the border here, so this little wooden frame here, would also get scaled. And that might look very ugly or bad, and we don't want that. And there is a solution to that, so that the scaling of an image is only happening to a specific part of the image, let's say. And the solution for that is a so-called 9-patch. What is a 9-patch? So there I will add this link to the video description below as well. You can create 9-patch images online and simply use them. So I use, for example, this website here since years. So it's very, consistent. So it's not going down, seems to be a good website. And it very easily creates 9 patches. So I loaded now our background image, and as you can see, there are now 9 areas of that specific image. So that's why it's called a 9 patch. And when it comes now to scaling, the border areas, so the 8 areas at the border are scaled in a special way, or maybe not scaled at all, I'm not 100% sure. And only the centerpiece here, that is then filled to make up the entire space that you need. And with that special technique, we could, for example, here define that our middle area, so the dark brown area in the middle, that will be the area that is scaled. And you see here, no matter how big I make now this graphic, the wooden frame is not scaled. So that one always remains the way it is here, which is normally what we want to achieve. If we wouldn't do that, so I can do it, for example, by quickly adjusting the 9 patch to be just a normal image, then it would get scaled like this, so that the wooden frame gets then very big and also not sharp anymore, as you can see here. So it does not look that good when we make it bigger. And yeah, the solution to that, especially when you work with small graphics or with this pixel graphics, is then a 9 patch area. So they're just created online. Normally it's making already a very good fit at the beginning, and then you simply save this graphic, and I think the XHDPI, one of these versions, just check of it, gives them the best result, and then just use of that. So I think those are the different resolutions, and maybe the highest one, I cannot remember, gives you the correct solution for the pixelated graphic. And code-wise, so in our code, we don't need to change anything. So from our skin, it's still the getDrawable function. LibGDX or Scene2D does everything for us in the background to correctly work then with a 9 patch graphic. So it knows when something is a 9 patch. And how does it know that? So let's download that one here. So what we get out of it is then a file which has this .9 name at the end. So this file extension at the end. And the only difference to the original graphic is, you can already see it here. So this is not the perfect version because the border here looks a little bit different, but ignore that for now. The important part is that there's 1 pixel on every edge. So top, bottom, left, and right, with this black bar here at the end. And according to this black bar information here, LibGDX in the background knows how it needs to scale the 9 patch. So the information that we have on the website, so what are the different 9 patches, so how is this area defined? This information is stored, let's say, or provided with this black border or black edge pixels here of the graphic. So that is coming into addition, and that's the only difference between a 9 patch texture and a normal texture. And yeah, for this user interface, for the background frame and also for the foreground frame, I already created those 9 patches, and we can simply use them now. So in our skin file, we have now additional drawables. So let's call it the frame background and the frame foreground. And as mentioned, those are 9 patches, but again, code-wise, we don't need to touch anything. Also the region, we don't need to provide this .9 or anything. LibGDX simply knows it when looking at that file. It somehow knows that it's a 9 patch and does then everything correctly for us. Okay, so then coming back to our game view, so there now between the enemy information and the player information, we want to add now our pop-up. So what we have here, I simply created here another table within the table. The background of this table is from our skin, and it's the frame background graphic or frame background drawable. Again, we need the get function in here, which I need to add manually. No idea what that is or why that's happening. And we want to have a label, of course. Text just for now. This is a test. And we want to have a specific style, which we are also going to create, that we have an example for that. And there normally I also create an enumeration because again, I cannot remember all the different styles that I will create in the project and all the different strings. So normally I create an enumeration for that. So there we will create a frame label style, and from that we get the skin key. And as always, like before, we want to adjust here the label a little bit. So we want to align it to the top left, so we don't want to center the text, for example. Then we want to wrap our text, so if it's very long, just make a line break automatically. And we want to adjust the label cell here. So we want to expand it, so whatever space is available, make that available. So in our case, that would be the size of the table, which is the parent of the label. So we want to expand it to that. We want to fill the entire space, and we want to make a padding on top, bottom, left, and right a little bit. You see that then in a moment. So make the label a little bit smaller than the table itself. And the label, the table cell as well. That one we want to expand, but we give it a hard-coded size here, so a width of 130 and a height, for example, of 90. And we want to position it at the top, and also a line break again for our player character information. Good, so what we are missing is currently here this special label style. So let's create that now as well. So going back to our skin file, there we create a new enum class for our different label styles. For now, we just have a frame, and the skin key is simply the name from the enumeration. And let's make it lowercase again. So let's remove this default label here. Let's keep it because we need that part here, but the default label, we don't want to have that anymore. So we create now a new label style. That's the only one that we use for now in this project, and it's from this frame label. The font is then there. We also improve on that, but for now, let's just copy down the font from here. So that is the line that we needed. And there's something in addition that we are going to fix then in the next round. First of all, let's see the result for now. And this label has a specific background, which is the frame foreground drawable. Okay, so now we can import the label here. And let's get again the result of our user interface. Okay, that looks a little bit weird. That's not what we want to have for now. So we already see the table background with a little bit of a scaling and with the 9 patches working. Then we have our label, which actually has a huge text. We are going to fix that as well. We have the foreground of this label as well. We wrap it. And here we see from the debug lines here at the top, we would also have our enemy character information. But currently it's covered by the label because the label is so huge. So we are going to fix that. So what I normally do, let's also introduce that here. Normally you don't just have one font for your entire user interface, because you might have maybe one for a title area, one for a normal text area, another one for something special. So normally you have multiple fonts. And what I do here as well, so I follow the same approach. I create a new enumeration, let's call that fonts, and there I define the different fonts that I want to load for my user interface. So for us here, for now, we just make one example. So we have our default font. There we need to provide the atlas region, which would be this font wide, and also how big it should be. So normally a scaling, because I don't want to create the font again and again with the hero tool. So normally I also just scale it like we did it with the damage font before in our live system. So what does this have? So it has an atlas region key, which is a string, and it has a scaling, which is a float. Then we have a skin key. So what is then used? So similar to the labels that we had here before. And there, for example, let's call it always font. And then it's the name. And again, it's lowercase. And we also need a path to the font file, which is in our case here always the user interface folder. Then the atlas region key. And at the end, it's the .fnt, because that's the extension of a font file. Okay, and with that, we can now load all the different fonts to the skin and also automatically dispose it then when we dispose the skin. So we simply go over all our font enumerations, and for each font, we are going now to store this font with the skin key, and we create a bitmap font. So the font file itself is the font path, and the region that we need is the atlas region key. And we want to adjust the font here because we need to set the scaling again, which is from our enumeration, the scaling value. Okay, let's import here the function. So now below here, what we can now do, we want to have something similar here. When we specify a font, we want to have something like this. So here we can take over the getter extension function that we wrote at the top, but now we pass in here the font. We return a bitmap font, and here we make a call to the skin get font function, which is the skin key, And with that, we can now write something like that, which is also great for future styles that we are going to create. So now we can access a font like that. We also create all the fonts here available, and that should still work. So let's try it out. It should now also be smaller because we scale it down. Yeah, so that looks now a lot better. So now also this foreground here of this font, or background of the label actually, is not so big anymore. So everything is now visible. And yeah, so one small trick that I quickly want to mention here. So there's an easy way to make the text here in some color. So let's make, for example, test. We want to have that in red. And there is some built-in functionality in Scene2D. So when you create the bitmap font, you can set that the markup enabled is equal to true. By default, it's false. And with this markup, there is some new functionality which is now available. So in our game view, where we have our test text here, we can now write something like that. So I think it's bracket hashtag, then red, green, blue. So the RGB values, let's say. And an empty bracket will clear the color. So let's make here an exclamation mark at the end. So if I remember correctly, so that should make our text now red, because we have FF for the red value and 0 for green and blue. So this is the markup that we now enabled, and with that we should already have some colored text. Yeah, exactly. So you see now test is now written in a red color. So this is a small trick. So this markup enabled. With that, you can quickly color your text information without the need to, with here, or to, for example, create a red font version, a black font version, whatever. You can simply do that with the markup very, very easily. And one last fix that we are going to make. So you see here, the text is actually on the edge of this background graphic, and we want to have the text inside this frame actually. And there is also a small trick that we can do. So when we go back to our skin with our background graphic here, we can adjust it. And say, for example, that the left width is 2 pixels, the right width is 2 pixels. And for example, at the top, we want to have also 1 pixel. So this is, you can imagine it like a padding. So when the label now gets rendered, and when it renders now the text, so the bitmap font, it considers this information here as well for the graphic, and will now, when we start it up, hopefully it works. So now you see that this T is now moved correctly 2 pixels inside and 1 pixel down as well, so we don't collide here with the border of our graphic. So one way to fix that very easily and to move your text inside here is by setting this width and height information of the drawable that you set as a background for your label style. So this is one way how I normally solve that. Okay, and with that, a long journey so far, but with that we are done with the view part. So we have everything available. We have our player information, we have our label information, and we would have here the enemy information at the top. So let me quickly show you that. So we can do something like that. We also have some logic that the live bar can get adjusted. So from a user interface point of view, for now, I would say we are done. Of course, we will add some functionality that this gets faded in. Let's do that now. So we fade in this pop-up here as well, and also this character information here as well. Then we are done with the user interface part, and the only thing that we then need is a model in the background that updates our view, so that the view is then dynamically interacting with our game world. But for now, so the view part already looks quite good. Okay, so to fade in our pop-up information for the looting and also for the enemy information, let's go to our game view once more. And here just initially, so this character information has an alpha value of 0, and the same here for this table here of the label. So here also from that specific table, the alpha value is 0. With that, it's not showing up initially, and we are going to fade it now in. So we want to have something like that. So our enemy information, we again clear all the actions which are currently running, and now we add new actions to it. And what we want to have is actually a sequence. So we want to, let's also import that one. We want to fade it in. First of all, so let's say, for example, over 1 second, and the interpolation that we are going to use is a bounce in function, and then with a delay of 5 seconds, for example, we want to fade it out over half a second, and they're just a normal linear interpolation, and that would be it. So let me quickly get rid of all of that, then we can have it in one line. So again, a sequence, first action is a fade in over 1 second with this bounce in, and then with a delay of 5 seconds. So after 5 seconds, we fade out our enemy information. And we also need to provide a function for our loot popup. So let's call that, I don't know, just a popup. Then the info text that we are going to provide. And there we need to remember our label, because from that one we want to adjust the text now. So we have, let's call it the popup label, which is a label, and assign it down there from our game view. Okay, then the text, let's leave it empty now, because we set it then from the outside. And below here we have actually something very similar. So the popup label, we clear the actions, and we make a, let's make a very similar sequence like we have it here, but instead of bouncing it in, we just use a normal linear interpolation, and it should be a little bit faster. So maybe the fade in is only 0.2 seconds, and then with a delay of, let's say, 4 seconds, we fade it out again. So this is very similar. And of course, what we also want to do, we want to set the text of our label to the text that gets provided from the outside. And actually, we don't want to fade out and fade in the label. We want to fade out and fade in the table, so the parent of the label actually. So this one would be here from the pop-up label, the parent, and not the label itself. I think with the label itself, most likely it does not even work, because if the parent is still with an alpha value of 0, then I think the label will never show. At least that would be my assumption. Okay, and let's try that out as well. So let's go to our user interface screen here. Let's make a new function. So when we press, for example, E, then we call the, not num E, just the E button. Then from our game view, we call the pop-up function. And you found something cool. And let's make that red as well again. And let's try that out. So now, initially we should not see the label and the enemy information. Okay, so now I press E, which fades in now this table, and after 4 seconds it fades out the table, which is great. Okay, and the same for the enemy information. There we press, I think, 4. So now we have this bounce in effect of the enemy, and after 5 seconds it should fade out again. Yeah, which is great. There would be a problem now when we spam the buttons. You see, it always fades then in. Same with the label a little bit. So what we want when this fade in effect is currently in progress, then we don't want to fade in again. And what we just want to do, so for example, the enemy information gets called again with a new enemy and new live. We simply want to delay the fade out again to this 5 seconds. So we just want to reset, let's say, the fade out when one of these widgets is already showing, so that we don't bounce in again and again and again. So we don't want that. And to solve that, we simply need to make a small check here. So if here the enemy information alpha value is 0, so it's not visible yet, then we want to do those two things. And otherwise, we want to reset the fade out delay. There we create a new function in a moment, and the same is here. So if the pop-up label parent is not visible, then we fade it in, and otherwise from this parent we call the same function as above. We also make this reset fade out delay. And what is this function doing? So this is an extension function to an actor. And we know, so our action, which is on these actors, is a sequence. From the sequence, we want to get the last action, which is a delay action, and that one we want to reset. So from our actors, we get, first of all the actions which are available. Then we filter for a specific instance. We only want to have sequence actions. Then we get the last one, or null if there is no action. And if there is one, then we know this is our sequence action. And there is a delay action, which again is the last one from here. And let's cast it to a delay action. And then the time of the delay, we simply reset it to 0. So now it starts again. So the delay action, just that you see it, it has a current time, so how much has already passed, and it has a duration, so how long should the delay be. We don't want to touch the duration, we simply want to reset the time to 0, so that the delay starts again and again. And with that, that should solve our issue that when something is currently fading in, that we don't fade it in again and again. We simply, in that case, reset the fade out delay. And that should be really now everything that we need for our user interface. And I think that was the tough part, but also the hopefully interesting part for you. So we made now a user interface stage. We created a custom widget, so our character information. We made some interaction so that we have some fade information or actions, fade out, fade in stuff. We have this bar, so like a live bar and so on, that we also have that available, which is also great. We have this delay action as well. We reset something of that. So I think there's a lot of things that we have covered now, also the table and the layout and how everything works with the skin. So that was really, I guess, the tough part, what we are now missing. So this is just a test screen. It has nothing to do currently with our game. What we really need now is the interaction with the game. So when our player takes damage, we want to adjust the life bar here. When we loot the chest, we want to have the pop-up here. And when we damage, for example, an enemy, we want to show how much life is left here from our enemy. So something like that. And for that, as mentioned, because we are using this model view model approach, we are going to implement now the view model, which is our game model. Let's call it like that. So our game model, what does it need? It needs access to our real model in the background, so our game. So first of all, we need access to our entity world. Oh, not box2D world. We need our entity world, and we need access to the stage, because our logic already is publishing some events. We are going to add some new events now, and this model is reacting to events. So for example, when an entity gets damaged, there will be an event, and then this model is doing something. And when the model is doing something, the view knows about it with this data binding that we are also going to implement now, and the view is then adjusted accordingly. So this model is an event listener from Scene2D. So therefore it needs to implement the handle method, which we are going to implement in a moment. And for now, we need, for example, access. We need to know when an entity is a player. So we need access to the player components, which we can get from our world. We need access to our life component as well, because we, according to the maximum life and the current life of an entity, we adjust the life bar. And we need access to, for our enemy information, what kind of enemy is it? Is it a slime or maybe another enemy? And let's read that from the animation. So there we have this atlas key for the animation, which refers to, for example, the slime graphic. And according to that graphic, we will know what kind of icon we display in the user interface. So we will read that from the animation. And the important part for the view actually is, so we need some information for the player life. We need some information for the enemy life, and we need some information for the loot text. So these are the properties where our view will bind to. So those get bound to the view, and whenever those values change, the view is then updating accordingly. And how does that work? So what I did then in some other project was that I created again some event system only for the view. So I would implement something like I don't know, game UI listener, and that one has then, for example, on player life change, on enemy life change, etc., etc. And the view then simply implements these this listener, registers to the game model, and then whenever those events occur, the view will update accordingly. That's working. I think it's also a nice solution, but that has the downside. Whenever I want to add a new property there or something new, I always need to adjust here the listener. I need to add a new function to my view, and it's a little bit annoying. So it's, yeah, I always need to adjust quite some code pieces to make that happen. So I thought of how could I implement something there in a generic way. Then I had a look at the Kotlin delegation, the built-in delegation, but somehow I think it did not really help me. At least I did not understand how I could use that to make that happen the way I wanted to, what I wanted to achieve here. So what I did, I implemented my own property binding logic, let's say. And what we do here now is that we create a new class to make that happen. So I called it a property change source. And what that one is doing, so you can register a function to a source that gets executed when a specific property gets changed. So for example, when the player life property changes, then execute a specific function. And with that, the view can say, okay, hey, model, whenever your player life changes, let me know. Then I adjust, for example, the player life bar. We implement that in a moment, then it makes sense to you. So what we need there, first of all, this thing can never be created on its own. That does not make sense. It always needs to be a subclass of that specific property change source. Then what we need is listeners map. Why is it a map? Because you can register for a specific so-called K property. I explain that in a moment what that is if you never heard of it. And then a mutable list of a function that takes just one value. I also explain that in a moment. And then execute something. And that's it. And to make more sense out of it, there will be a function available, a reified function. I also explained that if you never heard of that. So this is some, I would say, advanced Kotlin stuff, but very cool Kotlin stuff in my opinion. So there we also get the property of a specific type and the action that should be executed, which takes in the value of that specific type and executes something. And with that, we get the actions which are currently registered from our map. So there we make a get or put call. So if something is available for that property, we get it. And if nothing is available yet, then we initialize it with an empty mutable list. Then we need to cast it to a mutable list of type t. So a function which gets in this t value and executes something. And then simply to these actions which are already available, we add that additional action. And this cast is always safe, so we can suppress the warning here on this method. So that might be a little bit confusing for newcomers to Kotlin, maybe even users who already use Kotlin. So let me explain a little bit what we are doing here. So again, the idea would be, let's quickly go to our game model. So let's assume we have an instance of our game model. So model equals game model. And we know this model has a player life property. So what we want to have in our view is something like this. So we want to have, for example, model, then on property change. Then when from that model the player life property changes, then we want to execute a specific function. And we get in here the player life value, and for example adjust the life bar, set value, I don't know how we call it correctly, we see that then in a moment. We want to pass in something like that. So what this is this property binding that we want to achieve. So from our model, when a property change and what kind of property, so in that case this player life property, then our view, also here that you are aware of that, that would be the view code. Then we want to execute an action, and this action takes in a value. So this is that value t here, because player life is a float property. Then with Kotlin and with this reified functionality, this action already knows that the value that gets passed in here is also of type float. And then we want to do something with that float value. Same, for example, with the loot property. So there we have something like, what was it, loot text, I think we called it, doesn't really matter. There we get in then the text information. And in that case, so there we want to set then from our label the text equal to the text that gets passed in here. And this text will be of type string. So because of this reified function or reified functionality, which simply is a Kotlin way, in my opinion, a very nice way to already at compile time know what type is this t, so the generic type t, what is it? Is it a float? Is it a string? Is it an integer? And already at compile time, because this is an inline function, it will add that specific piece of code to that area where we are writing code like that. And yeah, with this reified, it knows already at compile time the correct type, and we can then already use the correct type in our code, which is very convenient, and in my opinion, a cool and nice way to make then this view react to model changes. One thing that is not so nice, so of course, when our model now, let's go back to our model quickly, that one needs to implement now a property change source. And of course, now everyone that has access to the model also has access to this listener map. We don't want that. So normally you would make it private, but that does not work, of course, because this is an inline function. And as mentioned, that piece of code that is mentioned here is then actually like copied to the area where we call this on property change. And since this would be a private property, of course, the function which is called, or the class or area, wherever we would call this code, cannot access this property because it's private. That will not work. So this is the problem, let's say, of this inline. But there is a solution for that, so we can make it internal. Then somehow it is private. I think it's available then only in this package from what I know, but not from the outside. And internal still would not work, but there is an annotation which is called published API. Don't ask me about the details, but in the end, we achieved then somehow that this listener map is still not visible to the caller side, but we can still use it in an inline function. So this is all that thing that you need to know here, and I think this is the most complex part that you need to know here, or understand here. But it's then very convenient. You will see that when we come to the view with the data binding. And also just one thing, so K-property, this is also some standard stuff in the Kotlin standard reflection library, I would say, and that simply is so this property is then an instance of one specific property. So for example, this player live property of the model instance, and the property has a specific type. So is it an integer, is it a float, is it a string? And that's why in our case it's of type T, and the value that this property will have gets then passed into this function. So this is this T argument of the action that we are going to implement. So I hope that somehow made sense to you. If not, please let me know in the comments below. Maybe look at it again, read a little bit about it, but that's a little bit of I would say, an easy way to implement this data binding. Of course, it's not super complex and does not support all the things that we need, but it's an easy way to support it. And yeah, this is what we want to achieve. So with that function, we can register functions to a property change source, but we also, of course, want to call then those different functions which get registered for a specific property. So that's why a source also has a notify function, where for any property, the type here does not matter. It gets in a value of a specific type, and then simply from the listeners map, we get all the actions which are registered, and if it's not null, then we call each function and pass in the value. And because the registering of such an action is happening here, if I would say in a type-safe way with the reified function, we can leave that here with this wildcard and this any value, because at the code part where we are writing this action, we already get the correct type, and there we have the type safety which is necessary. The calling part and in the background, we don't need this type safety anymore. The important part that it's when we write the code, so that when we write the action, at that point in time, we want to have the type safety. And yeah, so coming back now to our game model, now we need to do something, of course, when this player live value changes. Then we want to notify, we want to call this notify function that we have written here for our, for example, player live property. So what we do here, we simply override the setter of this player live property. So the default implementation would be, if you've never seen that in Kotlin, we override the setter function. We also want to have that private because we want to set this value only inside our game model and not from the outside. We could do that, but it's better to have that normally just in that specific class, because otherwise you might set this value everywhere in your code base, and then it's not so nice to debug it and understand it. So as a best practice, let's make that private here. And the default implementation is that the backing field of that property gets set to the value that gets set. So for example, if we would say here player live equals 2, then the value would be 2, and the backing field in the background of this property gets that value set. So this is the normal implementation of the setter if you would not override it, but we want to do here something in addition. So we want to call here now our notify function. The property is the player live property, and the value is the value that gets passed in here. So here also return true for now. So what is happening now, so whenever we set now the player live, so for example, like we had it before here with this 2, then before the value gets set, we notify or we call all the different actions that got registered for the player live property, and we pass in the value. So in this case, the value 2, we pass that to that different actions which were registered. So this is how I solved this data binding in the model part, at least. In the view part, we see that then in a moment, but in the model part, I solved it like that. So let me know what you think about that. Also, the experts there with Kotlin out there, what you think about that. Maybe there's a better solution. I don't know, but I like that approach so far. Okay, so the same thing, of course, needs to be done for enemy life and the loot text. So let me quickly implement that as well. Okay, so here we also have now the setter for the enemy life and the setter for the loot text. And what we need, of course, so that we don't forget that, so our model will be an event listener. So from the stage, we also add the model as an event listener so that it can then listen here to the different events that we're going to implement in a moment, like the player gets damaged and things like that. So let's combine now our view with the game model. So let's go back to the game view. Here in the model view model pattern, the view gets access to the model. So that would be the game model in our case. And now, because we have this model here available, we can now bind to the different properties. And you will see now, in my opinion, the advantage and the convenience of the approach that we have chosen. So this, at the top here, we have the user interface. And here we have the, let's call, I don't know, UI, or let's call that here data binding. So from our model, since it's a property source, we can call this on property change. And from our model, when the player life changes, we want to get here the player life. And what we then simply call is our player life function from below with the player life that gets passed in here. And because of this reified functionality, as I mentioned before, the Kotlin compiler knows that this will be of type float because the player life property is a Kotlin property of type float. So that would be that. Then we have also a loot text property. Another on property change from our loot text. And there we call our popup function with the loot info functionality. And then the last one on property change would be the enemy life. And there we want to set the enemy life to the enemy life that we get passed in here. Let's quickly also just, not sure if that is correctly working, but let's just create here another function. And there, instead of the player info, we will make the enemy info life with the percentage. Okay, and that would be it. So this is the data binding. So we register ourselves to the different properties here and can directly write the code that we want to do when the value here changes. Okay. Also in the game view now here, so in this extension function, we also need the game model in here that gets passed. And also in our UiScreen, we also need to create now such a model. So let's create here a game model where we pass in a world. Let's just make an empty world for now and the stage. And here we also pass in the model, and that would be it. Okay, and now theoretically here we could change these calls here and use our model, but for that we would need to publish some events that we have not implemented yet. So let's create one very simple event when the player gets damaged, and then change this that we see the interaction between the game model and the game view and the data binding. So from what I remember, we have an event file exactly. And there, let's create a new class. For example, EntityDamageEvent, where we take in the entity that got damaged. And for us, that's sufficient for now. And this is, of course, of type entity. Okay, and now our view model. That one is now listening to a specific event. So when event is a take damage event, then we want to check, is it a player? So we check, is the entity in the player components? If when it is a player, then we want to change the player life to something, and otherwise we want to change the enemy life to something. And for that we need the life component. So from that entity that gets damaged, we get it, and then we simply have the life divided by the maximum life. And the same for the enemy. And I think here we always added something like this. So here return false, and otherwise always return true. Okay, so now when such an event is happening, we get the life and everything, and the life changes or the enemy life changes, and we should see that then in our view. So in our UI screen, we need to quickly make a player entity to test all of that. So let's adjust the code here a little bit. So we have here also an entity world. And let's remember just our player entity here can actually be a constant, and our player entity is from a world, a new entity, which has a player component and it has a life component. Where we have maximum life, for example, is 5, and current life is also 5, for example. So that should be sufficient for our testing purposes. And now let's change the code here. So here when we press now 1, we fire an event, which is the EntityDamageEvent, which takes our player entity. And that's it. So there's no logic in our test screen here. So to see that something is really happening, let's change the life here to 3. Then the life bar should get adjusted. So let's see if that is working, because then we are almost done. Okay, that took me now quite some time. But, so first of all, it is working, but there's something interesting that I did not know. And the stage clear call here internally actually also clears the listeners automatically. Don't ask me why, but that was the problem why the view model could not get any events, because it got removed as a listener. So now here in our test screen, after we clear it, we also need to register the listener again. For that test purpose, it is totally fine. So what we can do now, we can now test this event that we are publishing. So I press 1, and as you see, we are actually only adjusting now in the model the code. I showed it then in a moment once more as a recap, and the view is already reacting to that. So everything is looking now really, really great, and we are almost done. So just once more, so we are publishing an EntityDamageEvent here, where our model is reacting to that. And if it is a player, which it is, it calculates this player life dot the maximum life, which in our case is 3 divided by 5, that one here. And by only setting this player life, we jump into here, which makes this notify call. And our view, so our game view, has this little action here that when the player life changes, then it changes this life information of the character information. So all this interaction, all these actions, everything is working great, which is awesome. So the only thing that we are missing now is for the rest of the cases, which we simply quick and dirt implement the remaining events. I think you got the idea now how it works and how you could set up such dynamic user interfaces. So now it's really just publishing those different events and reacting to them. One simple one which we already have available is the EntityLootEvent. And there, for example, we can set the loot text to "you found something useful." Let's make this red again, or to change it up, let's make it green. You found something useful. Okay, so also let's switch now to our real game to test and everything correctly. So we set here the game screen again. And what we also should do now, so this loading and disposal of the skin, for now, let's just move it to the game itself. So there is a create function in the KTX game. Which we already have. So here we simply load the skin, and when the dispose function here gets called, then we dispose the skin. So we don't need to do that in our screens anymore. We can also remove it from here. And now our game screen should already have that available. And here now, what we need to do, we do that. I'm now thinking in our show method, we could set the view, but let's do that in the constructor. So we just take over from our UI screen that piece of code here. And here is our UI stage. And that's it. And the model is a game model, which takes our entity world and I think the game stage is used in our case for the different events. So that should now already do it for the looting. Okay, so we have our player here. Then let's move to the chest and open it. And ta-da! We already have our pop-up. So everything is working there automatically because that event was already published, which is great. In our live system, there we are going to publish now the damage event so that that is also working. So for example, here after we adjusted our live, we use our game stage, which we don't have here yet. So let's bring it in. Okay, so here we want to fire our new event, which was the entity, how did we call it? Damage event, and pass in the entity from here. So now whenever an entity gets damaged, this event is now also fired, which means when our slime is now attacking us, we should already see. Oh, did we write it with a small g? Let me check that. But that should be then already it. So then this one should already working. Or did I think we in the YouTube tutorial series I did not use a qualifier at all for the game stage. Okay, so let's see if our slime attacks us, and then the life of the player already gets adjusted. Perfect, so this is also working. Now the only thing missing is that for enemies, we want to have a pop-up here. Also when an enemy is moving to us or attacking us, for example, then we also want to have this enemy pop-up at the top. So that's the last piece of information that we are currently missing. So what we could do, we have, for example, I think attack task is how did we call it? In the AI package, there should be different actions. And there is one for attacking, exactly. And here, what we are doing now, so here, for our entity, we are going to fire an event. And for example, let's call it EntityAggroEvent. So it found something that needs to be attacked. And that would be the entity itself. And of course the target that it has. Not sure if we have all of that available. Let me quickly check. So we go to our AI entity. So first of all, we need to have access to the entity itself here for our event. So this is the source. So the source entity which aggroes now the target. Okay, so here I solved it a little bit differently, or we solved it differently. It's this nearby enemies first or null. So this should be the target actually. So in our case, when the player gets attacked. We don't really need that for our user interface, so I will skip it for now, but you can check on the GitHub project, for example, how I did that. So there, this first or null, I simply use there a separate property to get that back and pass it to the event, but in the end, we don't really need it. So let's go back to our actions, and there, let's just say we want to fire a new aggro event, and there we just need to, for example, that the slime is now aggroing the player, and then we want to show the pop-up of the enemy. So that's totally fine. So first of all, let's implement this fire event that takes an event of Scene2D. And what that does, simply from the stage, fire, and then the event. And our AI entity does not have access to the stage yet, but now it needs that because sometimes it needs to publish certain events. So we get here a stage. Okay. So then it can do that. And of course, when an AI entity gets created, we now need to pass in the stage. So let's see, new instance creation, there should be 1 or 2 areas. So here in the AI component listener, we also get in our stage and also in the state components. There we also need our stage. Okay, so that should be it. So now here we need a new event. So also let's go to our event here. That also has the, yeah, let's just call it entity for now again. So this is just the source entity, which is getting the aggro and attacking something. So then we can publish it here. And finally, coming back to our model, that's the last thing that we are going to implement now. That's this EntityAggroEvent. And there we want to get the type out of it and set then this, or show then this enemy pop-up, for example. So we want to check the entity type, which is from the animation components. Not 100% sure, it should always have an animation, but to be safe, let's assume here it can be null. And if it has something, then we want to get here the atlas key out of that animation. Okay, and then simply, so if it has a specific type, then we update the enemy information and pass in the entity from our events. And actually we do the same here at the top. The reason is that the way I implemented it, and maybe that's not the best way, is this blinking mechanism when a new entity gets shown. And then once it's shown, I don't want to show the enemy information again, or this blink animation again. And also the live. So for example, when a new enemy gets discovered, then the live bar should get adjusted immediately when the enemy switches in the character information, and not interpolate slowly when changing there. So that's why we need to keep track of what was the last enemy that is part of this model logic here. And when we simply get the same entity again, then we just adjust the live with this interpolation effect. And when a new enemy is shown, then we want to immediately switch the live bar to the value of the new entity. So that's why we need a separate function here to solve that. Maybe there's a better way to do that, but for now, let's just roll with that. So we have the last function most likely for today. We get in an entity, and here we now do something. So first of all, we need to get the live component of that entity, and we assume it always has one. Then we set the live to the value that we had below as well, so the live divided by the maximum amount of live. And as mentioned, we need to keep track of what was the last enemy. So here we need to keep track of the entity, of the last enemy entity. So let's do it then here. So if last enemy is not equal to the entity that we get in here, let's also call that enemy in here. Then we set it first of all. So this entity was the last entity that we got in here. And then we adjust the type. So all of that here is then happening above. So here we get the enemy, and let's do it then like this. So if it has a type, then we want to set the enemy type to the type that gets passed in here. And this is one new property that we are also going to quickly add, and then we are done. So this is a string again. Where our view will then also register to that specific type. And with that, we should get then the correct behavior in the end. So here, update enemy, and here also simply update enemy. Okay, and the last thing, so GameView, there we already have a registration to the enemy live when that changes. And one more thing that we need, we want to react when the enemy type changes. And there we want to do certain things. So when the type equals slime, so that is the atlas key, enemy type, then we want to change from the enemy info, we want to change the character to the slime drawable, for example. And we also want to set the live immediately in such a case. So here we get the live from our model and switch it immediately. So this is when this type information changes. And now, I'm of course an idiot. So it is working, so we actually end up here, but we of course implemented already there a specific method, so to show enemy information. There we pass in the slime and the enemy live, and I think now that should be really it. Wow, that was really a long coding session for me as well. I've expected it to be longer, to be honest, but not that long. I underestimated that a little bit. So now my brain power is also a little bit down. So let's see, when is the slime aggroing us? Come on, little slime. Otherwise, we will also add something when we damage a slime that it shows up. But yeah, so what was our logic again, that the slime? Okay, finally. Great stuff. So that everything is now updating correctly. Slime is getting slime HB is also getting removed correctly. So here the implementation of the AI, I remember that one as well, is not as perfect as with the real game. But yeah, something is working. So when this slime is now attacking us, and then this pop-up here is also showing up at the top. It's not ideal, it's not perfect, but I think you get the idea, you get the concept. And with that, that's actually it. So wow, let me recap once more. So we implemented now this user interface. We added a user, we did not add that, but we had a user interface screen to make a quick mock and test our user interface without the real game world, because that's way faster to implement the logic and everything for user interface, because then, as you saw, just with pressing buttons, I can test the different behavior of the user interface and how things should happen. We created this skin to have the different style for our, for example, we had the label with the background and everything. We created a custom widget with this character information. We used some nice LibKTX extensions and updated the DSL a little bit to also bring in our widgets with this LibKTX. And we also created this view model, which encapsulates the different logic that we need for our specific view, in this case, the game view and the game model. And the model reacts then to different events, changes then the properties that it has, and with this property binding mechanism we can then update the view in a very nice and efficient way with the small little actions here that we can register. And yeah, that's it. I hope you liked it. I hope it was not too much and too confusing. Again, I tried to add some links in the video description and some timestamps to which hopefully helps to split up and digest this long video in small bits and pieces. And with that, that's it. Thanks for watching. Have a nice day and bye-bye. Hey guys, so this part is actually now recorded after the initial coding session of the user interface. So I looked through all the video raw material, and before I wanted to render it, I wanted to elaborate on certain things that I missed in the video, which I noticed, and I just want to fix this now at the end now of this part. So for you, everything is together, but for me, you will notice it here on the date. There's actually 1 or 2 days, I think, since I recorded the last session. So first of all, what I never mentioned is, why do we even use the Scene2D DSL? So for example, this with the table here, and then we have the label there, and also at the area where we create the game view, which was in our user interface screen, for example. So why do we even do that? I never mentioned the benefit of that. We just did it. So we use this Scene2D DSL of LibKTX. And the reason, or one of the main reasons for me, is simply the visualization. Because you can imagine you might have a maybe more complex user interface. So for example, here you might have a table. Then below the table, you might have maybe some label. You maybe have some text in there, or a text area, then maybe also a slide or whatever that was called. Then there you have another table and maybe some nested other tables, so some complex things here. And in my opinion, personally, when you have the DSL like that, and also with the nesting, when you go inside the different levels, it's already pretty clear how your user interface is structured and how it should look like by just looking at the code. Normally, with the normal Java approach and the normal Scene2D approach, you would have more something like this. So for example, you have the table where you create a new table, then at some point from the stage you call the add actor method, as we have seen that. There you add the table, then maybe here you have also to the table you add the different childs and things like that. Let me also show you that. So there I think is a add child or add actor as well. There you add, for example, another label and things like that. So then you have everything on that, you have it on the same level, and you always need to look, okay, where do I add now what, and what gets added to which level here, and it's, in my opinion, not that nice. So definitely with the DSL approach and the nesting and so on, I think it's also, first of all, easier to write it down because you don't have all these additional add calls and you don't need to remember all your different user interface actors in a separate variable, because you can simply write it down in this nice, in my opinion, intuitive DSL syntax in the end. So that was the benefit why we did all of that, and what was the reason for all of that. That was the advantage of using the Scene2D LibKTX DSL. Then what I never showed was actually this button. I noticed that, so we implemented that this R is simply hiding and showing, and therefore resetting the user interface. And I mentioned something there that I wanted to get the quick feedback, for example, when I'm developing the user interface, but I never showed you how that works. So let me quickly go to our application, and we change there now to the UI screen again, so that we see that. So here, let me quickly change from the game screen again to the user interface screen, and let's start once more in the debug mode, so that I can show you now what I meant with what actually the R button is doing, and what I meant with getting the quick feedback during the user interface development. So for example, we have now something like that, and let's take, for example, our table as an example. So here, let's imagine, okay, it's maybe we want to have it a little bit bigger, and maybe we want to have some padding and things like that. So let me quickly go to the game view, and for example, let's say we don't want to have a width of 130, we want to have, for example, I don't know, 180, and maybe a height of 110, just as an example. And now we can reload the classes, so a hot replacement. The hotkey, at least for me in IntelliJ, is Control Shift and F9. The first time it normally asks you if you want to reload the classes that you have changed. So normally I make this tick box and then say reload. So now the new code would actually be available, but since we are inside the game view, the game view does not get created automatically, or especially the constructor code where we set up all the widgets does not get called again. So we need some sort of mechanism to restart or reload our user interface, and that is where the R button comes into play. So when I press now the R button, you notice now, so we already see our table now got here a little bit bigger, because now the game view instance was created again with our new configurations, and that is the advantage of that. So this is why this R button, so this reload action, was there available. One more example, let's maybe say with the padding here, we are not happy enough. Maybe we want to have a padding of, I don't know, maybe less. Let's say, for example, 7. Again, we reload the classes. You see that at the bottom below when building something. We come back here to our screen. Let's show up again the table here. Then we reload it. And now we see here the padding is now also a little bit smaller, so now it fills up almost the entire space inside this background. So that was the reason of this R button, the reloading and everything, and how I normally develop the user interface. Of course, the hot reload does not always work, so there are some limitations. So for example, adding a complete new method to it, or for example, a new property to the class, then of course it cannot reload the code. But as long as nothing big changes, so just some minor things like some user interface adaptations, as we have seen it here with the padding or the width and so on, or maybe adding new widgets and everything in there, all of that will work, and then simply hot reload the classes and restart or reload our screen. And with that approach, I don't need to always stop the application and start it again. So that was that specific topic. Then one small thing, which is actually a bug also in the GitHub repository, but it does not matter for our case. So as we have seen in the game view, actually I pass in the skin, which contains all the styles and so on, and then we read, for example, the different regions from the skin and the label style and so on. And I did not pass that actually to other widgets. So for example, the character info here, I did not pass in the skin, which in our case and in all my games that I developed so far, it does not really matter, because I normally just have one skin, and this is always the Scene2D default skin. So it doesn't matter what kind of skin I actually use. I could also simply remove this argument, because I won't use it, but just theoretically that you have seen that as well and know why that is passed. So you could have, of course, multiple skins for your game. So for example, a typical example would be in the web again, where you have a light theme and a dark theme. Then you would have a skin for the light textures and a skin for the dark textures and the different styles. And then depending on if you, for example, pass in the light theme or the dark theme skin, then of course all the actors and widgets which are created by yourself should also get the correct light theme or dark theme skin. So to be 100% correct, we should provide here the skin as well that gets passed in, let's say, to the root or to the parent of all our user interface stuff, and correctly pass that through to the other widgets as well. Again, in our case, it does not matter. It's not really a problem because we anyway just have this one skin, so the Scene2D default skin. But keep that in mind if you want to support multiple skins maybe in your game, then don't forget to correctly pass the skin to all your different widgets that you're going to create. Okay, and the last thing, because I looked once more a little bit if there would be a possibility to improve my approach here with the data binding, where I've always overruled the setter method, and it's basically always the same. I just want to have this notify here before of the specific property, and that's the same for the player life, enemy type, and loot text as we have it here. And normally when you need to copy paste something like that, there is actually a better solution for that. And indeed there is, because we are using Kotlin, and Kotlin, luckily for us, has a built-in delegation support, which I also briefly mentioned in the video, but I did not know how we could use that, because let me open up the documentation. I looked at some default delegation stuff. So for example, this by lazy, not sure if we use that in the tutorial, but that would be, for example, if you use that already in Kotlin, that would be a delegation to, I think it's called a lazy property, or it's a lazy object in the background of a specific type. So in this case, it would be a string, and then it does something. And there's also observable and other things. You can read that up. I will link it in the video description below. And what we simply do, we want to have something similar like this. So my idea was that we can write, coming back to our code, something like this. So we can write var player life, and then, for example, I called it property notify, where we provide the default value, and that would be it. And then we can simply skip that. Let me just comment it out. So we want to have something like that. And then we can also replace all the other occurrences here with this new property notify delegation. So we can write something like that. And how does it work? So basically, when you write a class, so they have an example there on the homepage as well. Let me zoom in a little bit. So for example, here, from this string property, in this example, they have a delegate class, which is described below. And this delegate class must implement a getter for if you have a property with the val keyword, so with a constant, because somehow, of course, you need to provide a value for that string. So in this case, it returns that specific string here, so this getter, and always must have the same format, which is also mentioned here at the top. You get the reference of the object which is holding the string, so in this case it would be an example instance, then the property itself, in this case it would be this p property of the example class, and then it must return in that case a string, because that is the type, which in that example they return that. And if you want to have a variable, then you also need to write the set value function, which also has exactly one specific syntax. So again, this reference, the property, and of course the value that you want to set, and then you need to store that. And now we are going to quickly implement something so that we have a delegation available and can write this by, I call it this property notify option, that we can simplify that code here a little bit and make me, and hopefully you as well, 100% happy, and that you also learn something a little bit. Okay, so let's quickly go to our property change source file. And now here we are going to implement this new stuff. So as mentioned, we need some sort of a delegation class. I called it, for example, property notifier, and in our case, it's a property of a specific type, and just as a limitation for us, but of course you could change that and adjust it to your needs. For us, it must be an object which is not nullable. So any object which is not nullable, that is our type T, and there will be an initial value. So the startup value for that property, which is of course also of this type T. And in the end, what we need to store or keep a value of this type T, which has initially the initial value. And this is then in the end the property that we create. So coming back in the game model, so this player life or this enemy life here, that is then not a float in the end. It's then this property notifier class instance. So the float is actually wrapped inside. So this will be our float value, and it's wrapped actually in this property notifier. So there's a little bit, of course, of an overhead, but I think it's worth it for the nice readable way that we can create there. Okay, then we need, so now we store this value and have the property correctly available. Then we need this getValue function, where, as mentioned, it gets this reference, and in our case we can also limit that, because we want to call then this notify function, and also this delegation, this property notifier, should only be used within the property change source. So here we can already say that this reference will be a property change source at least. So it's not any object, it's really a property change source. Then it also gets this k property, and it returns the value of type t, which in our case is then this value that we already store. And the final thing is then the set value, which again gets this reference, which is the property change source. It gets the property again, and it gets the value that we want to set, which is also of type t. And now here comes the special part. So here, when a value gets set, then from our property change source, we want to call the notify function for the property, and we pass in the value that we want to set. And of course, we also want to set the value directly here. So maybe do that before, so that when inside the notify function, any logic needs to access the value itself, then it is already correctly set here. And that is all we need. So that would be our delegation class. And now, to be a little bit consistent also with other Kotlin syntax style, we again write this reified function here to have the type safety available, and also to have this lowercase function then. So let's call it, for example, property notify. That one gets an initial value of type t, returns a property notifier of type t, and that one is simply a new instance of a property notifier, and we pass in the initial value. And that is all we need. So now, coming back to our game model, we can already, as you see, we can now write something like that, and we can also remove this code and do the same thing for all of our other properties. So enemy life, we have the same here. The enemy type is a string, so the initial value here is a string. And for the loot text is the same. So there also the initial value is a string, and that should be, oh, and it's not equal here. It's of course this by, because we delegate the property to something. Okay, and that's everything that we need. So that improves the code a little bit, and I think it's a nicer solution. So just once more to explain it. So this will be our delegation class, and maybe also there's no magic or anything happening in the background. Maybe also as an exercise that you see that once more. So this player life will be in the background and still be just a float, but as mentioned, wrapped inside this property notifier class. And what Kotlin is doing with this by keyword, it simply creates also a setter and a getter for this player life property. And the setter function and the getter function are then simply calling those two functions here. So this is everything that Kotlin is doing in the background for us. And we can also check that. So for example, we go to tools, Kotlin, and show the Kotlin bytecode and decompile it. So that gives us then the Java code, and there you see, so we have now a player life, enemy type, and loot text. So those are our properties which have this notification in place. They are of this type property notifier, and for example, for get player life and set player life, as you see, it's a simple call to this get value and set value function. With this is the first argument, so this is this reference, then this is the property, and then for the setter also the value which gets passed into the set player life. And you see here it's really of type float. So nothing special in there. It's just yeah, let's call it a little bit of a nicer syntax or a nicer code that we can create there. And one thing, because with that actually it would not work, and they are not 100% sure why, but what I imagine is that we have a problem here with that one here, because from that specific instance, so in the game view, we have the game model, and there we refer to the player life property. And that does not work anymore. What then really works is that one. So instead of using the property of the instance, we need to use the property of the game model class itself. And I cannot really tell you why. So there may be also, if someone perfectly understands it, would be great. What I could imagine is that, of course, the class itself has some sort of definition, and of course some sort of property definition, and with that way we reference the property in general, so that let's say the static property of the player life of the game model class. And when we write it like that, then we are really referring to the property of that specific instance, so the player life of that specific instance of the game model. And for whatever reason, here I'm not really an expert, the property that gets passed in here in this delegation class, so those two arguments here, this, at least for me, was always the property of the class itself, so of the game model, and not of this reference. So that's why also in the game view, we simply need to adjust it to the game model, and that's it. So let's quickly try that out. Let's go back to our game screen one last time, and let's get attacked by a slime to see that the user interface is still working. Or maybe also just open a chest. I think that's a little bit easier for us for the testing purposes. So let's go there. Okay, so there's already the pop-up. There is already the pop-up for the loot text as well. So everything is still working, but it got a little bit beautified, I would say. And with that, that's now really it. So this is all I wanted to show you, and that should hopefully cover everything. I hope you liked it. Leave me please a comment if you have any questions, and also if everything was clear and you enjoyed the part, then please also let me know. If not, please also let me know. Feedback is always welcome, especially constructive feedback. And with that, that's it. Have a good day and bye bye.